Is on polynomial functions of higher degrees. So we're going to be spending the rest of the chapter talking about polynomials. So we're going to be doing things from algebra 2, like the P over Q, right? Rational roots theorem. We're going to be talking about end behavior. We're going to talk about how to graph polynomials. So we're doing a lot with this. Long division. Do you guys remember long division, synthetic division? Yeah, we're doing all of that throughout this chapter. So we're going to start with the basics today. So a polynomial is by definition something that's like x to the n, right? So n is some kind of positive degree. And the degree of the polynomial is the largest degree of the individual pieces. Do you remember that? Neil, can you put your computer away? So it says, write the polynomials in descending form and find the degree of the following polynomials. So descending form we sometimes call standard form. So if we're writing it in standard form, we're just going to write it so we start out with our highest exponent. So we'd have 8x to the 9th. We don't have an 8, like an x to the 8th, but we do have a 7. So minus 6x to the 7. No 6, but we do have a 5, so plus 7x to the 5th. No 4, no 3. We do have a 2, so minus 10x squared. And then plus 9. Okay, so do you guys all remember standard form, what that means? Really, I think standard form was just invented to make it easier on math teachers to grade your papers, because if you write it in one standard way, we can quickly grade it. So, all right, so if I'm finding the degree, our degree is going to be that largest exponent. So in this case, our degree would be a 9. So our degree tells us a lot about our polynomial. So do you guys remember this part? Does it look like this on the ends? Does it look like this on the ends? Does it look like this on the ends? Or does it look like this on the ends? So 1, 2, 3, or 4?
2.
It looks like 2. It's going to look like an x cubed, right? It's odd and it's positive, so it's going to look like positive x cubed on the ends. Okay, so we're going to talk about that in just a second. So the next one is going to be 10x to the 10th. Nope, that's not our highest, is it? 4x to the 13th plus 10x to the 10th minus 3x squared plus 8x plus 6. That would be our standard form. So our degree then would be 13. So again, it's an odd degree, so it's going to do what Maury calls the John Travolta, right? Where one goes up, one goes down, like that. Did he call it that last year? No, he didn't? I'm surprised. You guys are just getting... You're too young these days. You don't know who John Travolta is.
Jimmy's. Yeah, that's true.
They call it sprinkles, like on ice cream, Jimmy's.
Jimmy's? Oh, that must be a weird Boston thing. He's weird. All right, so end behavior. So that's what we're saying here. So if it has an odd degree and the leading coefficient is positive, it's going to look like x cubed. So x cubed on its ends looks like this. So we could be doing lots of things in the middle. It could go up and down, up and down, up and down. It could do lots of things, right? But we know that in the ends, it's going to be like this, okay? So if the leading coefficient is negative, but it's odd, it's going to be the other direction, which is what I was saying was what Maury usually calls the John Travolta. Both of those are, you know, putting your fingers up in the air. Up and one's down. Even degree, that's going to be like x squared. Oops, so it's going to be where both of them go up. And then negative is where they're going to both go down. Okay, so if you remember in Algebra 2, we wrote this a certain way. So we would say, as x goes to infinity, don't write this, I'll tell you another way to write it. So as x goes to infinity, y also goes to infinity. Okay, and what that meant is as x got really big to the right, so as I went to the right, my graph went up. Does that make sense? So y got positive. And so this one we had written as x goes to negative infinity, y goes to, it goes down on that side, so negative infinity. Does that make sense? You guys remember those? We're going to write this differently in pre-calc because it's leading, this is why it's called pre-calc, it's leading to calculus, okay? So in calculus we use something called limits. So the way we're going to write this is we're going to say the limit, and then below limit we're going to write real tiny. So we're going to say x goes to infinity. So the limit as x goes to infinity of our function is equal to infinity. So limits are the y value you're getting closer and closer to as x goes in a certain location. So what we're saying here is as x gets bigger, as x goes to infinity, where does y go? Y goes up. It goes to infinity. So it's exactly what we did in Algebra 2. We're just writing it differently. So on the left-hand side, I'm going to say the limit as x goes to negative infinity of my function is negative infinity. On the second one, I'm going to say the limit as x goes to positive infinity of my function. Where does the y value go? It goes down, right? On the right side, I go down, so negative infinity. And the limit as x goes to negative infinity, so as I go to the left, my function goes up to infinity. Does this make sense? Do you guys get it? It's just a different way of writing it, so don't let the limit scare you. All right, on the other ones, we're going to say the limit as x goes to positive infinity, so as I go to the right for my graph, what happens to my y value? It goes up. It goes to infinity, yeah. The limit as x goes to negative infinity of my function also equals infinity. It goes up as well. Does this all make sense? The limit as x goes to infinity of my function would be negative infinity. It goes down. And same thing for this one. So the limit as x goes to negative infinity of my function is also negative infinity. You get used to writing limit, 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 limit in calculus. I used to let my students write L squiggle for limit. And then I had a student by the name of Leonidas Georgicolopoulos, was his name, Lee, who did that on his AP exam. And then I stopped letting people write it as L squiggle because he was like, oh, I didn't know I couldn't do that. I was like, I was just letting you shortcut for my class, not for the exam. All right, anyway, so number one. So identify the leading coefficient, degree, and end behavior. So our leading coefficient is the number all the way out front. It decides whether we have a positive or a negative. So if it's positive x cubed, negative x cubed, positive x squared, negative x squared. So one of those four possibilities. So our leading coefficient in this case is -1. Our degree is 4. Our end behavior, since it's negative and it's x to the 4th, it's going to look like this on the ends, right? So that's our end behavior sketch. So if your book was asking you to write limits, you would say the limit as x goes to infinity of f of x is negative infinity, and the limit as x goes to negative infinity of f of x is also negative infinity. So again, we're saying as I go to the right, this is what x goes to infinity means, I go down. As I go to the left, I go down. That's how that's read. All right, our leading coefficient on the next one is 2. Our degree is 5. Our end behavior sketch is it's positive and odd. So show me with your hands what it does. Yeah, good. So it's going to look like this on the ends. So we're going to say the limit as x goes to infinity of our function is equal to what? Infinity. And the limit as x goes to negative infinity is negative infinity. Perfect. Good? All right, so to identify whether it's even or odd and positive or negative. So do they go in the same direction on the ends? No. So this one's odd. And is it positive or negative? Does it look like positive x cubed or does it look like negative x cubed? Yeah, it's negative. So odd and negative. So how about the next one? Even and negative. Perfect. Do you wish the whole test was like those questions? Those are my favorite. Easy. All right, so if you remember, books can ask lots of different things. We can phrase the same question in several different ways. So if I say something like, find a root of the function, or find a 0, or find the x-intercept of the function, or find a solution to the polynomial equation where you have a polynomial equals 0, or find a factor of the polynomial, all of these things mean the same thing. Okay, so x-intercepts, roots, zeros, those are all the same thing. So general rules for factoring. So we always pull out the greatest common factor first. If there are 4 terms, we do factor by grouping. If there's 3 terms, we do our 2 sets of parentheses. And we also look to see if there's 2 terms. In that case, it would be the sum or difference of 2 cubes or 2 squares. We can't do the sum of 2 squares, though. And our trinomial thing is the reverse factoring. So we're going to practice factoring over the next couple days. So the first one says find the zeros of the function. So do we have a GCF, first of all?
Yes.
No, we don't. We don't have anything we can pull out because we have that 1 x cubed, right? So this is 4 terms, so we do our factor by grouping. So we're going to split it down the middle, and we're going to ignore the left side, or the right side of the equation right now. So only looking at the left side, if I have x cubed minus 6x squared, yes, there is a GCF. So I'm going to pull out the GCF from just this part. So I have an x squared I can pull out. When I do, I have x minus 6. On the other side, I want to have an x minus 6. Is there something I can pull out? Yeah, I can pull out a 2. And I always pull out a number and a sign, so I'm going to pull out plus 2. Okay, so if I had this, you guys would totally know what to do on the next step. Like if I had x squared y plus 2y, you'd be like, oh, there's a GCF. The GCF is y, right? And then you would pull that y to the front, and you'd be left with what was not the y, the x squared plus 2. That's what we're doing on the next step. It just doesn't look like that. Do you guys see how we have a GCF again? X minus 6 is now a GCF. So we pull the entire x minus 6 to the front, and we're left with x squared plus 2. Okay, and you can FOIL that out. You would see you get the same thing. Is this me beeping or you? So we end up getting this. We then set it equal to 0 to find the zeros or x-intercepts, right? X-intercepts set the y equal to 0, and we set each piece equal to 0. So I'm going to have x minus 6 equals 0, and I have x squared plus 2 equals 0. So the first one, I get x equals 6. The second one, I don't get a real solution. But we are going to talk about imaginary solutions or complex numbers, right, later in the chapter. So let's go and find it. So I subtract the 2 over, so I get negative 2. I take the square root and write plus or minus. This is all coming back to you. We get plus or minus I root 2 would be that answer. Now I think on your homework, it's not going to ask you for complex solutions yet, so don't worry about that on your homework. But we're going to talk about complex numbers. We'll review that as well. All right, so the next one, yes, we do have a GCF on this one. So I would probably pull it out before you even start. All right, so if I have a 3 in common, I pull that out, so I get 4x cubed plus x squared minus, not 6, 8x minus 2. And then I can just factor by grouping on that part that's inside. So if you forgot to pull out the GCF, it will work out fine. You'll just kind of continue factoring and pull out a GCF later. So I'm going to have an x squared. When I pull out the x squared, I have 4x plus 1. You need that plus 1. A lot of people forget that. So if I want a 4x plus 1 over here, and I have negative 8x minus 2, what am I pulling out? Yeah, negative 2. Perfect. So when I do this, I have 4x plus 1 pulled to the front, and I have an x squared minus 2. But I also have that 3, so I'm just going to pull the 3 out. And I'm finding the zeros, so I'm setting it all equal to 0. So the first one, I don't have 3 equals 0. That doesn't work. Do you guys see if I had 3 equals 0, that's not giving a solution? So I say 4x plus 1 equals 0, and x squared minus 2 equals 0. So when I subtract the 1 and divide by 4, I get negative 1/4. What do I get for the other one? Plus or minus the square root of 2. Perfect. So I have 3 solutions. Since it's x cubed, you guys remember the maximum number of answers you can have is 3. All right, so that's starting that next section for you, so we'll finish this up next time, but you guys can go on and start that homework as well. Okay.